Ever wondered how hot the sun really is? As the colossal furnace of our solar system, the sun is the source of the light and warmth that nurture life on our planet. Born roughly 4.5 billion years ago from the gravitational collapse of a region within a large molecular cloud, the sun has been radiating its heat ever since, fueling life on Earth. At its core, the sun is a nuclear fusion powerhouse, where hydrogen atoms combine to form helium, releasing a vast amount of energy in the process. It's this very energy that heats the sun's core to staggering temperatures, reaching up to 15 million degrees Celsius. Yes, you heard it right, 15 million degrees. Yet despite its fiery intensity, the sun provides just the right amount of heat and light to Earth, maintaining the delicate balance that allows life to flourish. Imagine, without the sun, life as we know it would cease to exist. Have you ever pondered about what's inside the sun? Let's take a journey to the heart of our solar system. The sun's structure is made up of several layers, each with its own unique role. At the very center lies the core, the sun's powerhouse. This is where nuclear fusion occurs, turning hydrogen into helium, and releasing an incredible amount of energy in the process. This energy then travels outwards, making its way through the next layer, the radiative zone. Here, energy moves slower, taking thousands of years to pass through. Next up, we have the convective zone. Here, energy is transported by convection, similar to how water boils in a pot. This convection churns the sun's plasma and creates solar granules visible on the surface. Speaking of the surface, let's talk about the photosphere. This is the layer we see from Earth, the one that emits the sunlight we receive. It's also where sunspots occur, cooler areas that appear darker than their surroundings. Above the photosphere, we find the chromosphere. This layer is visible during total solar eclipses as a thin red rim. It's also where solar flares and prominences originate. Lastly, we have the corona. This is the sun's outermost layer extending millions of miles into space. It's incredibly hot, even hotter than the sun's surface, and is responsible for the solar wind, a stream of charged particles that flows out into the solar system. So, the sun isn't just a bright ball in the sky, it's a complex, layered entity. Did you know the sun is a stage for some of the most spectacular natural phenomena? This celestial body is home to solar flares and sunspots, two of its most captivating performances. Solar flares, the sun's explosive outbursts, occur when magnetic energy that is built up in the solar atmosphere is suddenly released. These flares emit intense bursts of radiation across the electromagnetic spectrum, from radio waves to X-rays. On the other hand, sunspots are dark, cooler areas on the sun's surface, formed due to the sun's magnetic field's fluctuations. These spots serve as the birthplaces for solar flares. Now, these solar phenomena don't just put on a spectacular show. They can affect Earth, too. Strong solar flares can disrupt radio communications and cause spectacular auroras. Scientists around the globe keep a close watch on these solar events using advanced telescopes and satellites. They study and monitor these phenomena to predict their occurrences and mitigate their potential impacts on Earth. These solar events, though distant, have direct impacts on our daily life. Ever thought about the sun's lifespan? Now let's dive into the timeline of our sun. The sun, the fiery ball of gas that illuminates our days, is middle-aged in star terms. It's about 4.5 billion years old. Yes, billion with a B. But don't worry, it's not about to burn out anytime soon. The sun has another 5 billion years before it exhausts its hydrogen fuel. But what happens then? Well, it's not going to go gentle into that good night. Instead, it's going to transform. The sun will start using helium as fuel, causing it to expand and swallow the inner planets, including, unfortunately, our own Earth. But even then, the sun's story doesn't end. After it exhausts its helium fuel, it will shed its outer layers and shrink down to a white dwarf, a dense, dim remnant of its former self. This white dwarf will continue to cool and fade for billions of years, but don't worry, this is not a doom and gloom story. It's a reminder of the grand scale of cosmic time. It's a reminder of the fascinating, ever-changing nature of the universe we live in. It's a reminder of our sun's journey, a journey that's still in progress. While the sun's death is billions of years away, it's a reminder of the ephemeral nature of life in the universe.